All right, welcome everyone. Thank you for joining this afternoon or morning, depending on your time zone. First off, my name is Larry Morris. I'm one of the local New England system engineers, and over the next, let's say 45 minutes to an hour or so, I'll be presenting a webinar on Prism Pro. So Prism Pro, as the title suggests, it's going to be leveraging AI and machine learning to streamline your multi-cloud operations on Nutanix. All right, so this webinar right here, the Prism Pro, is just one of many. So if you were with us maybe about, I think, 2 weeks ago now, we had, what's new with Nutanix. It was a full solution or portfolio overview brief of Nutanix. And as you can see from our schedule, over the next couple of weeks or so, we'll be covering AHV as well as some of our ancillary products within the portfolio. But today, we're going to be just focusing on the Prism Pro product for this webinar. So in terms of the agenda, pretty simple here. We'll start off first with just an overview of Prism Pro, or more specifically Prism. So not necessarily a prerequisite or requirement, for this webinar, but if you have, knowledge of Prism, meaning that you're a Nutanix customer, certainly helpful. But as I just said, not necessary or not a requirement for this particular webinar. So we'll cover an overview of both Prism Element as well as Prism Central, and then we'll dive into the two underlying technologies that really drive or really make Prism Pro operate. Those being CrossFit as well as Crossplay. So you may have noticed that on the second and the third bulleted items, it spells out XPlay and XFit, but us Newtons or Nutanix employees will actually pronounce these technologies CrossFit and Crossplay. So I won't get into too many details here, because I'll be doing more of a deeper dive on the upcoming slides. But just in short, the CrossFit technology, it's an existing technology already there within Prism Pro today, and it's really leveraging that machine learning and artificial intelligence AI to help us make intelligent decisions, to detect performance anomalies, as well as to do other features such as just-in-time forecasting. And then the other technology, Crossplay, you can really think of this as codeless task automation. So if you're familiar with the if this then that type of technology, that's what we'll be covering. Use of Playbooks a little bit later on in the webinar. And also note that we'll be using some slides for the first half of the webinar, and then we'll jump into a live demo to cover these these features of both CrossFit as well as Crossplay. And also, I should have mentioned this a little bit earlier. We do have a chat window that's open. It's being monitored by panelists. So if you do have any questions throughout the webinar, please feel free to use the chat window to ask those questions. So what I'm showing here is just really the portfolio of Nutanix, and we're not going to cover the whole portfolio during this webinar. Some of these other products in the portfolio will be covered in the upcoming weeks, but really what I wanted to focus on today is just where exactly does Prism Pro fit within the portfolio. And if you look at that middle 1/3 section, the Nutanix Essentials at the very far bottom, that's where Prism Pro is. So really in order for Prism Pro to work, you have to be leveraging Nutanix Core, which is on the far left of the slide. So Nutanix Core, including the operating system, so the Acropolis operating system, AOS, are included hypervisor. But remember, this is Nutanix, so it's kind of bring your own hypervisor. But included within Nutanix Core is the Acropolis hypervisor, or for short HV, and then lastly Prism. So Prism itself is really just think of this as the management UI or management plane to manage your Nutanix Enterprise Cloud. Also, I will note that since Prism Pro is a separate product, it is licensed differently, or it actually is a licensed product. So you would have to purchase a license for Prism Pro in order to use that feature. However, we do offer a 60-day trial as part of Nutanix Core for Prism Pro. All right, so just kind of going high-level overview of Prism. Just want to touch upon here is that, as I mentioned, on the previous slide, Prism itself, it's the management plane or management, web-based UI that you would use to both manage as well as monitor your Nutanix Enterprise Cloud, right? So whether that Nutanix Enterprise Cloud is using AHV, ESXi, or another hypervisor, or really even independent of the underlying hardware, right? So whether it be NX or one of our OEM hardware providers, Prism's going to work with all that. So in terms of both manageability as well as monitoring. So in short, think of your infrastructure management as being done via Prism, right? So, whether it be, adding a node to an existing cluster to expand that cluster, make it larger. Maybe you want to create a storage pool, or from that storage pool, carve out a container, a volume, a share, or even, just for example, create a VM for an application. That's all going to be done within Prism. So, really, you can think of Prism as your one-stop shopping for all your needs within your Nutanix cloud. Prism is also the gateway for access to other products within our portfolio. Meaning, one example is if I want to do any type of, let's say, application automation orchestration, that type of feature functionality would align to our COM product, which is Cloud Application Lifecycle Management. And COM itself would be accessed via the Prism console or the Prism UI. Additionally, we'll talk about operational insights. So since Prism's going out there and monitoring your Nutanix cluster or clusters and all the individual hardware components and nodes and whatnot, we're collecting a lot of rich data. So based upon that data collection, we can then apply that machine learning and AI to actually go out there and make intelligent decisions. And we'll touch upon this a little bit later on when we start talking about the Crossplay Technology, but being able to understand the performance or behavior of the system, so of the VMs, the hosts, the clusters, to establish baseline performance behaviors, and from there being able to identify any type of anomalies in performance. We'll also, throughout the demo, we'll give we'll spend just a few minutes here in the demo later on talking about the planning features within Prism Pro. Specifically in regard to the just-in-time forecasting. And we'll also do a live demo of how I can go ahead and look at an existing cluster and go ahead and model, or really just without actually doing it, add a workload to an existing cluster to see what the impact would be on that cluster in terms of really 3 KPIs in terms of CPU, memory, and storage. All right. And like I said, it wasn't a prerequisite for this webinar, but so for those not seen the UI or Prism in the past, this is an example of what the Prism dashboard would look like. So as I mentioned before, it's it's web-based. Also, it's highly customizable. So, the dashboard itself is comprised of multiple widgets. So the widgets being, those squares within dashboard, and each individual user can go ahead and add and delete widgets that are applicable to their role within the organization, or even just it could be as simple as just rearranging the order of those widgets. All right. While I'm on the Prism slide, I will just kind of take a step back here. So we know that the webinar today is on Prism Pro, but like I said, I wanted to kind of touch upon just Prism in general for those that may be unfamiliar with Prism. So with Prism, there's really 2 flavors of Prism. We have what we call Prism Element, or for short PE, and we also have Prism Central, or for short PC. And I'd say really kind of like the main difference between these 2, and these are both part of the our core offering, is that Prism Element is used to manage a single cluster, versus Prism Central, or PC, is used to manage multiple clusters. So think of it like this. If you have one site, you're fine with just using Prism Element. You can also use Prism Central, right? But if you have multiple data centers, maybe multiple robo sites, in other words, a large Nutanix footprint, then it would be best, we prefer that you would actually use Prism Central to monitor that type of environment. Or even if you start using our SaaS offering with AWS, that could all be managed within Prism as well. But I just wanted to show you, what we look like in terms of the UI. In terms of, visualization management, the example I'm showing right here on the slide is just, what does the topology look like, and really network topology look like, showing, the relationship between a VM, a host, and a network switch. And then we can kind of, dive into cluster health, right? So we could take a look at, CPU, memory, IOPS, throughput, latency. We can also take a look at the individual, what we're looking at here is the individual blocks or nodes. So really the hardware that can be also viewed within Prism, and not just looking at the hardware itself, the disk layout, but also the performance of those nodes or those blocks. And we'll cover this particular feature, this one right here. We're looking at right here. This is the capacity runway, and we'll cover this a little more in depth later on during the live demo. But this is really just kind of a sneak preview. And really, what we're showing here is that this type of feature, functionality within Prism, it allows us to take a look at a cluster and looking at that cluster, really understand that how much time, right, in terms of days, do we have until we run out of a critical resource? And we really, to make it really simple, we just focus on 3 critical resources, or KPIs, right, key performance indicators, those being capacity, CPU, and memory. So we're going to tell you, based upon current usage, when you'll actually, run out of that critical resource, right? So that's really leveraging that machine learning and AI to make those type of predictions within Prism. And then, lastly, we'll cover this as part of the live demo, but really the Crossplay technology really encompasses Playbook. So really what a Playbook is within Prism Pro, we're going out there and we're setting a trigger for an event. Once we set that trigger for the event, we can define an action or set of actions to take once that trigger or event occurs. And then lastly, as part of the Playbook process, we're just going to go out there and save and enable that playbook, right? So it can be as simple as 3 steps right here, or we can make it a little more complex depending on the number of actions we want to define within that playbook. And like I said, we'll cover this a little bit later on. I'm going to give a very specific example during the live portion of the demo. So kind of going back now, so now we did the high level overview of Prism, right? So PE, PC. Now we're going to go back to the Prism Pro. And the way we have this, I have the slide divided here. Is on the left we have the Crossplay technology, and then on the right we have the Crossplay technology, right? So they're really the 2 underlying technologies that really fuel Prism Pro. You'll notice in the center of the slide it says new. Really, what we're saying new is that the Crossplay feature is new as of our 5.11 release of the product, which was earlier in the fall. So it's relatively new, but not new. But once again, the Crossplay technology, this is going to be leveraging the machine learning, AI to go out there and identify inefficient VMs, any type of performance bottlenecks or anomalies within your environment. And then that Crossplay technology, as we just discussed in the last slide, that's going to be going out there, and it's going to be the codeless, an automated remediation when an event occurs, right? So, I would say the most important thing to take away from Crossplay is that it's going to take out the manual steps or manual intervention that's required to address a problem or incident within your environment. So the example we'll show a bit later on is, what happens when a VM is running out of memory, right? So we consider that, that VM is being constrained from memory. Well, historically, what have to happen is, either that VM user or, maybe, an administrator, system administrator would have to, either receive an alert or be notified, by that VM user that their VM is, its performance is degraded, right? So the admin would go in, they would say, hey, the memory usage is higher than normal, hence the performance degradation. From there, they would have to probably snapshot the VM, maybe hot out a gig of memory or whatever it needs in order to bring it back to normal. From there, go ahead and re-notify the customer or the VM owner that memory has been added, and then go ahead and mark in the ticketing system that issue has been resolved, right? So a lot of manual steps there. And what we'll show is, via the use of a playbook, leveraging that Crossplay technology, we can actually automate all those actions or steps from the event to actually the resolution. All right, so what we're showing in this slide is leveraging that Crossplay technology, we have really 4 VM profiles or categories as to how we define inefficient VMs. So the 4 categories are as follows: bully VMs, constrained VMs, over-provisioned VMs, and inactive VMs. I think the names are somewhat self-explanatory. If not, I mean, I'm not going to walk read through every item on the slide, but kind of in short, a bully VM. This is kind of the VM you think of as a resource hog. So, in other words, it's consuming more resources than other VMs, and as a result, that's which will result in a victim or constrained VM, right? Which is our second profile here. And to kind of make it easier. These are just system defined, how we define a bully VM versus a constrained VM. That's all there on the description field with those bulleted items. But just kind of in short, bully using more resources, causing other VMs to starve. Those VMs that are quote unquote starving, those would be your constrained VMs or victim VMs. Over provisioned VMs, I think we've all seen this throughout the course of our IT careers, is that we'll have someone ask for a VM. They'll ask for, way too much, maybe, CPU, memory, or disk, and it's just wasteful, right? So it's inefficient. So just being able to identify any type of, over-provisioned VM, you can see, how we do that. And then lastly, identifying any type of inactive VMs, within the environment. So for inactive VMs, we really have 2 subcategories. We have what we consider a dead VM, right? So that's a VM that's been powered off for at least 1 month, right? So 30 days. And then the second subcategory would be a zombie VM. So a zombie VM, this would be a VM where we're seeing very little activity. So in terms of, IO as well as throughput over a 30-day period. So I guess kind of more of the story is, if you look at, over-provisioned VMs and active VMs, those are just, two inefficient types where we, as administrators can go through and actually reclaim resources within the existing cluster. So really kind of doing a cleanup first, right, of the waste versus going out there and just buying, more nodes to expand the cluster. So now we'll just take a quick look at the Crossplay technology for anomaly detection. So the way anomaly detection works is it's allowing us to look at the historical data that's being collected by the cluster, and from that historical data, establish a performance baseline. Now, that performance baseline or performance behavior will be based upon at least 27 or so metrics, and these 27 metrics are going to apply to 3 different entities that we're monitoring, right? So the entities being VMs, hosts, and clusters. And one question we have is, okay, that's great. Nutanix is going out there, they're creating a performance profile for maybe my VMs, my hosts, my clusters. But the next question always comes out is, what type of data is that based upon, right? So in our case right here, we're looking at least like 3 weeks or 21 days of data. From there, we're going to analyze those metrics, and then from there, we're going to consider to have or establish a normal behavior band, right, or normal performance profile. Also, from that collected data over that 3-week period, we can also accurately forecast or predict what the performance will look like over the next week or so, right, over the next 7 days. Also, I mentioned that these predictions or behavior bands are also taking into account seasonality, right? So if we see, say lower than normal CPU or maybe even memory usage on a VM over the weekend, and we know that's normal. Well, we're going to consider that normal over a base or a period of time because that's expected or normal behavior for that particular VM. And in terms of how often are we collecting these metrics from the VMs, hosts, and clusters? Well, that's happening every 5 minutes. So every 5 minutes behind the scenes, we're going to be collecting that information in an agentless fashion, leveraging all the data that's being collected via Prism. All right. And next, we're just going to kind of jump into the live demo. So for today, we're going to be covering our first demo. We'll be just going over the inefficient VM profiles, right? So those are those 4 profiles, we touched upon earlier, right? So this as an example, right? The bully VMs, the constrained VMs, over-provisioned VMs. Next, we'll just give an example of what anomaly detection would look like within Prism Pro. We'll also show you how to run a inefficient VM report, right? So taking a look at those 4 categories of inefficient VM profiles, and being able to run a report that you can actually send out via a PDF report you can send out to management or your team. And then lastly, we'll take a look at the Crossplay Technology, just-in-time forecasting, as well as what I'm calling predictive analytics, where I'm going ahead and I'm actually modeling me adding a VDI workload to an existing cluster to understand how it would impact that cluster's CPU, memory, and storage usage. And last but not least, we'll be touching upon the crossplay, and we'll create 2 playbooks. One, how to automatically add memory to a constrained VM, and then secondly, we'll take a look at one of those bully VMs, and we'll create a playbook so that we can actually quarantine that VM using the Nutanix Flow product. So Flow being our microsegmentation products for AHV, the Acropolis hypervisor. All right, so just bear with me a moment. What we'll do now is we'll just transition from the PowerPoint into the live demo. All right, so right now I'm just in I'm in Prism Pro, and we're looking at a live cluster. And just want to kind of point out once again, this is what a typical dashboard would look like within Prism Pro. As I mentioned earlier during the PowerPoint presentation, I can go ahead, I can add or remove widgets to my liking. You can see all the various widget options here on the left side. But for right now, let's just take a focus on the VM efficiency widget, which is right here. And we can see the 4 categories, right? So over-provisioned, inactive, constrained, and bully. What we'll do now is we'll click on right here, view all inefficient VMs. So this is giving me a list of all, so there's right now like all VMs, so all 75 inefficient VMs. I can go ahead on the right side, apply a filter. So if I wanted to focus on maybe just, bully versus victim, bully versus over-provisioned, I can do that right here. But we're just going to ignore that for a moment, and let's look at an example right here. So this particular VM I'm hovering over, DC2 North SE1. It's being flagged, leveraging that Crossplay technology as a inactive VM, and the reason being, it's been powered off for at least 62 days, right? So if you recall, Prism Pro is going to identify a inactive VM as being powered off for at least 30. So in this case right here, we certainly meet that criteria, and it's being flagged as an inactive VM. So, what I can do here is I can actually now go ahead and contact, that VM owner, right? Let them know that this VM has been powered off for 2 months to see if they still need that VM for that project. If they don't, this is a way I can actually go ahead and delete the VM and reclaim resources. And if we're talking about maybe it's a Windows VM, it also gives me the opportunity to go out there and reclaim a Windows license as well. So just one example to kind of be more efficient and clean up any type of waste within the environment. Another example let's give right here is just the very first row. So this VM right here, DC1 North SE, it's being flagged as an over-provisioned VM. And when I go to click on the efficiency detail, it gives me a description right there. So based upon really 2 criteria, right? So the max hourly average CPU. So in this case right here, we're saying that, for the max hourly average CPU, anything that's less than 20% over the last 3 weeks, it's going to make it flagged as an over-provisioned VM. So in this case right here, we're running at 4.38%, so a fifth of what we're expecting. Hence, we're saying that it's over-provisioned because we're underutilizing the resources. And then the second factor criteria, if I go back here, is looking at the max hourly average for memory usage. So in this case right here, if the hourly average for memory usage is less than 50% over a 3-week period, I'm identified as being over-provisioned. In our case, we're using 38.7% of the memory average memory usage. So it's also going to meet that criteria as being an over-provisioned VM. All right, so we'll just kind of go here. And next what we're going to take a look at is anomaly detection. So So we're going to focus on just, one particular cluster. We're looking at, two separate clusters. We're going to focus on this first cluster right here and look at any type of anomalies. We'll change the filter, but we're going to look at any type of anomalies, let's say within the last, 30 days. So we're going to click on this one right here, and what it's looking at is looking at a controller, right? So if you recall earlier when we were talking about anomaly detection, we're looking at, really, three specific entities: the VMs, the host, and that's the example I'm going to show right now. It's going to be a host as well as a cluster. So in this case right here, we're going to take a look at one of the hosts and see why it's being flagged as an anomaly for performance. So we're going to go into the metrics window. We'll let that load. And we can see right here, we have three instances of where we're seeing anomalies for the CPU usage, and they're all identified by that icon. So I can go right here to alert settings. I'm going to look at the underlying policy for this alert, and you'll see that same performance histogram will load in a moment. But really what I want to show is, so we know that the three alerts, but I can also show me, what can I do, right? So if I'm leveraging that machine learning or behavioral anomaly, I can go ahead and make changes here, right? So I can also either, let it be, system generated, system run, or I can make changes right here. So it's 100% configurable, customizable. Additionally, if I'm used to using static thresholds, I can also set static thresholds as well. So it's whatever, whatever floats your boat. All right, now we're going to take a look at capacity runway. So, as I mentioned earlier, capacity runway, really being, driven by, three KPIs: storage, CPU, memory. And what we're doing now is just, looking at ways we can just kind of optimize these resources. So in this case right here, you either reclaim, storage, CPU, or memory. So the first one we're going to leverage here is looking at those, inefficient VM profiles. So you see a couple of VMs that are over-provisioned, constrained, inactive, bully. So in this case right here, looking at the over-provisioned VMs, and we'll take a look at this VM. And the alert makes sense, right? So we're saying that it's really over-provisioned in terms of memory. So this would be an opportunity where I can go out there, contact the VM owner, letting them know that, hey, you're only using about half of your allocated memory. Would you mind if I went through and memory from 8 gigs down to 4 gigs, right? So I think you get it, right? It's just a matter of being able to identify areas where we can be more efficient and improve the allocation of resources. So now we're going to take a look at the VM efficiency report, right? So it's one thing to go into the UI and we can look at the 4 categories of inefficient VMs, but maybe a manager, director, or whoever the team wants to see a report. That's what we're going to show now. So this report can be emailed out. You can email one or many recipients. Let's just go ahead and view the instances of the report first. So you can keep multiple instances of the report. And I'll show you a little bit later on how to set the retention period for the number of instances. But right here, this will just be a PDF example of that report. So giving you all the cluster details, right? And then right here, list of inactive VMs, over-provisioned VMs, constrained VMs. So once again, breaking down the category by VM profile. And just, areas where I can actually go ahead and reclaim resources. All right, next we're going to take a look at a cluster efficiency report. So let's just see, where we are in terms of cluster resources. So, very comparable to what we just did, same type of process. First we took a look at a report for inefficient VMs, right, based upon those, those 4 categories of inefficient VM profiles. Now we're going to be taking a look at the overall cluster health. So I know I'm going through this pretty fast here, but really what I'm kind of pointing out here is that it just gives you a way to, instead of going into the UI and looking at the data real time, I can also schedule a report and have it sent out into a PDF. So it just makes it look, so for some folks, it just makes it a little more consumable and easier to view. All right. And also, I'm going to run through a quick example now of how I can actually customize. So we're going to kind of, in this actually, customize, one of these, CAN reports. So I'll add my title, optional description. And in this case right here, what type of entity do I want to create the report on? It's going to be my VMs. And in this case right now, I'm going to create a role and look at, specific VMs they're going to be on HV hypervisors. And you can see there's multiple categories to choose from. Next, I'm going to choose the columns, right, for the report. Now, in my case right here, you can see, the 4 categories, but we're going to do some custom selection here. So let's go ahead. We'll, for the report, this VM report, the name of the VM, its disk capacity, allocated vCPU, power state, as well as operating system. We'll scroll down. And for each one of these columns, you can see there's various operands you can choose from. So in this case right here, we're going to look at the average disk capacity for that VM. And the report itself, customizable. You can upload an organization image or a customer image, copyright information. Also set, I was talking about this earlier, the retention period, right? So how many instances or of the report do I want to keep, or do I want to keep, in this case right here, maybe just 1 week of the reports. That's defined here. Also going back at its schedule, how often do I want to send it out? Have the report run maybe during non-production hours. I set that right here. Pretty easy to set up. So have it run daily at 12:10 a.m. and then I'm going to select who I want the report to be emailed out to. I save it. And that's it. All right, and then the next the next feature we're going to take a look at the Crossplay technology. So let's get a moment here. I'll load that. So just a recap. So the Crossplay technology. This is where I'm going to go out there, and this is the whole automated or codeless task automation. So I'm going to go out there and create a playbook. So once again, in Prism Pro, I'm going to go to Playbooks. And I think, this should look familiar. We saw this earlier in the slide deck, right? So this is where, I look at the individual components of a playbook where I'm going to go ahead, define or set a trigger, define an action or set of actions, and then lastly, save and enable that playbook. So the example, we're going to show 2 examples for playbooks. The first being, how we handle, how do we hot add memory to a constrained VM? That'd be example or playbook 1. And then playbook 2 would be, how do we create a playbook to quarantine a bully VM via the flow product. Okay, so let's get started here. And these are all, so we're looking right here, those are just all pre-canned playbooks. So in this case, we're just going to leverage one of the canned playbooks. So really simply put, as part of the playbook, we call them individual plays. What we're going to be doing is defining the alert. We'll snapshot the VM, hot add a gig of memory, and then send out notifications via email and Slack to the customer, and then lastly, acknowledge the alert. All right, so the playbook has been created. Now what we'll do is we're going to take a look at our VMC environment, and we'll do a live example. So the VM that I have selected right here, this Tomcat VM, right now the allocated memory capacity was 9 gigs. I'm just going to run a script right here behind the scenes, and what the script's going to do is it's actually going to increase the workload on that VM. And as designed, what should happen is as that memory usage increases, I should also see the playbook will kick in, and that allocated 9 gigs of memory capacity will increment by 1 gig. So in a moment or so, once that script is done, we'll see the allocated capacity of that Tomcat VM being 10 gigs. And that's all by design, right? So the beauty here is that there's no type of manual intervention. No one has to go into notifications. It's all being done automatically as a result of the playbook. And I can go ahead into my playbooks and look at the individual plays that happened for this playbook. And I like this because it really kind of shows you what happens behind the scene, right? So we know we got the alert, we know we snapshot the VM, we added memory, but this is just a sample of the email notification, Slack notification that were sent out to the VM owners. So what I'm showing right here, just an example. This is 100%, the template's 100% customizable to whatever's applicable to your environment. So I just really want to show here is that there are multiple ways to actually notify the end user customer that this action was taken automatically. That way, it's business as usual. They can continue to use that application without any type of impact to their daily schedule. All right, and we're just going to create one last playbook, and that playbook is going to be for that bully VM, right? So, as we mentioned earlier, we have a couple different types of VMs here, right? Or inefficient VM profiles, right? So the bully VM, inactive, over-provisioned. We're just going to deal with today with just the bully VM, right? So this is kind of like that resource hog VM. Let's go ahead and we'll create an action. So we're going to take a snapshot of that VM. Next, we'll add an action. So we're going to quarantine via the flow product. Right, and I believe the flow product will be covered in an upcoming webinar, but just for today, think of a flow product as being the microsegmentation for the Acropolis hypervisor. And we'll go ahead and acknowledge that alert as part of the play. Save it, rename it, add the optional description, and we are done with that playbook. All right, and then really the last feature I just wanted to show, I'm going to go back into my live environment here. We'll start from the dashboard. I just want to give an example of, I mentioned earlier predictive analytics. So this is where I'm really taking advantage of the capacitor runway, just-in-time forecasting, where I can go ahead and model or simulate me adding a workload to an existing cluster. So let me just go ahead and kick that off. So in this case right here, I like having the search feature. I can just type in Runway. There we go, Runway. Okay. So in this case right here, we just have one cluster. We're going to click on the cluster name. And what I'll do is on the left side in this navigation pane, I'm going to click on capacity. So it looks very familiar with what we saw earlier. Now, in this case right here, plenty of runway, right? So plenty of, almost about a year plus before we run out of storage, CPU, memory based upon the current workload. So, you can see right here, this is, underutilized to say the least, but if I wanted to reclaim some resources, one can click on optimize resources. And this is where I can, really focus on the over-provisioned VMs or inactive VMs. And it tells me what my reclamation potential is, right? So I can claim really right here, a lot of memory and CPU just from the over-provisioned VMs. And then the same right here from memory and memory, storage, and CPU for the inactive VMs, right? So it's just a way for me to go out there, reclaim resources, clean up my environment, versus me trying to go out there and purchase more nodes to expand the cluster, right? So my philosophy is if I can be more efficient first, leveraging what I already own, let's do that before we go out there and make the decision to buy more. So just a way to optimize resources, but really what I wanted to show was how to simulate adding a workload to this existing cluster, right? So we're not actually adding a workload. We're just going through the simulation process of adding, in this case right here, a VDI workload. So in my case right here, I'm going to click on Add Adjust, right? So I'm going to add a workload. And you can see from the drop down, we have a number of, built-in or key-in workloads. I'm just going to today just make it simple. We'll focus on VDI. It's going to be a view environment, and let's change this to maybe power. We'll go with a power user. You can see I have provision type options here, but we'll just change the number of users to, let's just say 300. Just an arbitrary number. And in my case right here, I'm going to add these users. So by default, it goes 60 days out. But let me just go back a month. Let's just go. So we got today is the 17th. Let's just say, hey, we want to add it, I don't know, tomorrow as an example. Oh, here we go, next week. So the 25th. So by doing so, it changed if you recall earlier, right, we had well over a year before we hit our wall for CPU, memory, or storage usage. Now you can see right here, overall runway is 7 days, right? So in 7 days, we're actually going to be running out of, really just the memory, right? The CPU looks fine. Storage is fine. Still, plenty of runway there, but because of memory, that's really the constraint now by me adding these, 300, VDI users. What do I do, right? So in this case right here, it tells me what my existing, cluster is comprised of, right? So I can see all the details right here. It's a 3460 G6, right? So it's 4 nodes. What we can actually do is this is, leveraging that machine learning, that AI. We can make an intelligent recommendation as to what type of hardware you'll need to add in order to support this new workload. So in this case right here, it's an addition of one more node to that existing cluster, right? Also, what I really like is the fact that it's one thing to look in the UI at all this information. I can use a snippet, take a screenshot, but I can also just, very easily generate a PDF of this report. So we won't go through all 7 pages of the report, but just want to at least kind of show you what it would look like. So, so without, so if I were to add, simply adding that VDI workload to this existing cluster, what we're saying is that, within 7 days, we're going to be out of a critical resource, that being memory, right? Still have plenty of runway for CPU and storage, but in this case right here, memory would be the constraint within the cluster. If I add that additional 1 node, it brings me back to a year plus of runway for CPU, memory, and storage. And all the details about the workload, the existing hardware, that's all going to be within this report. Any type of usage, performance, current runway. So all these these various graphs right here show me what I have for CPU, memory, storage. And then what it would look like if I were to add that additional capacity or additional node to the cluster. And then lastly, we're just going to go back to the slide deck and just finish up on one last slide here. And this lastly, this may have been talked about during the first webinar, but just I just want to kind of recap with just talking about Nutanix support. So one thing I'll mention here is that we have support. 7 worldwide support centers, 24/7 support, 365 for all this on support. But really what I always like is kind of leaving, how like ending these webinars, WebExes is really talking about the Net Promoter Score. So it says 4 years, but really last 5+ years, we received a Net Promoter Score of above 90. So really what a Net Promoter Score is, the promoter score is how likely are you to recommend Nutanix to a peer or to a customer. So, average for the software industry, which we're in, Nutanix, is 30, right? So being at 90, we're obviously well above average. And I just want to make sure we point that out is that, we have that very high Net Promoter Score. And also, when you call in for support, there's no type of, tiered support. When you call in, you talk to the SRE, that site reliability engineer. That person, he or she, will be with you. We will be with you throughout the course of that case. So, just wanted to kind of end there. That being said, I want to thank everyone. Thank you everyone for the time this afternoon or morning, depending on time zone. And hopefully you can join us for our next webinar. Thank you.